Suppose we know that ax equals 2, 0, negative 1, 3 has no solutions, and that A is a 4 by 4 matrix. How many solutions does ax equals 0 have? Okay. So it's a square matrix. Square matrices are what you need in order to have the fundamental theorem of invertible matrices. Now, what have we got here? This statement, we've got no solutions here. So we have an ax equals b that has no solutions. So another way to say that, remember statement number, I think it was 2, although you don't need to have the numbers memorized. Statement 2 says that any ax equals b has exactly one solution, no matter what b you pick, right? So this is clearly false, because here's a specific b where ax equals b doesn't have exactly one solution. It has no solutions, right? Well, if 2 is false, then, for example, 1 is false. Okay, so what did 1 say? A is invertible. Is false. Or 5 is false. A row reduces to the, I guess, 4 by 4 identity. This is also false. So I know A isn't invertible. A doesn't row reduce to the identity. Now, do any of these help? Well, these ones don't help, but they are still results that we can say. What are we asked about? We're asked about the homogeneous system. Well, there's one result from the fundamental theorem of invertible matrices that talks about homogeneous systems. Ax equals 0 has one solution, the trivial solution. Okay? But if statement 2 is false, then statement 3 is false as well. Either, if one of the statements is false, they're all false. So our homogeneous system does not have one solution. Homogeneous systems have either exactly one solution or infinitely many solutions. So we conclude that this has infinitely many solutions. In fact, this is similar to one that we went through in the lesson. We went through that one kind of briefly. Here we've done this in a bit more detail. We found out that this tells us statement number 2. One of the statements is false, so all 5 of them are false. And from one of those, we were able to conclude what we were wanting.